be trying to have understanding and overview of different softwares for you. Um, Officially, um, so we will be starting with Python, visualization within the Python, the data sets. But still, I will guide you through other softwares as well. That at the end of this course, you will be having a familiarity with other softwares like um, mm, uh, Tableau, like Power BI. So these are the softwares that are very important for data visualization and exploratory data analytics. And whenever you are in the tech industry, so these two softwares, you will be interacting with these two softwares very much. Still, Google has another software studio called, it's also a type of data visualization software, but we will be focusing on Python, Power BI, basics of Power BI, and also the Tableau. For sure, we will be showing you some visualizations within Excel and Google Sheet as well. So there is no such difference between Google Sheets and Excel, but still there are some small differences. We will be proceeding with that as well. So let's start with our today's uh, presentation. Uh, we will be starting with matplotlib library for uh, data analytics, and um, we just want to see if there is no questions and everything is there, everyone is there. No, everything is, I think, everything is good. So multiple people wanted to join the call. So yeah, I think so. Admit them. Okay. Let's proceed with the matplotlib. First of all, before proceeding with matplotlib, this is what is matplot actually? Matplot is a powerful plotting library. It's just using for plotting. Plotting means visualization, which is for Python and allows us to create a variety of charts and visuals. We will be seeing which type of charts and visuals we can create. First of all, in order to use the matplotlib, we have to import the library. There are different submodels there, but we will be importing specifically the pyplot submodel. So from the main model of matplot, we will be importing the submodel. So if we matplotlib.pyplot, which means that which model we have to uh, import as PLT. So standard, they are importing it as PLT. So similarly, we have to import as well the pandas as PD we did previously. Import numpy as NP as we did previously. So these are the libraries that we want to import, for example. Now we will be proceeding with some very basic charts. Let's start with line chart. Uh, okay, in order to create a line chart, what is why line chart is important? So line chart is actually, it shows the trend over time. What what I mean by trend over time? If uh, if on the x-axis we have a trend of time, and on the y-axis we have um, data points. So we will be using line charts. And what does this line chart shows? It shows that how a variable changes based on, for example, time. So how a variable changes. For example, if you have company and you have, for example, profits, based on years. Yeah, you want to just see how your profits are changing. So just assume that you have we have a list of X. We will be assigning, for example, year 1, year 2, year 3, year 4, year 5, 5 years, yeah. And we have y-axis, for example, assuming that we have profit of 10,000, then we had 20,000 profit, then profit has been increased again to 15,000, then the profit increased to, for example, 25,000. So then at the end, it becomes 30,000. So this is how, for example, your plot is there. Yeah. Now, how to plot this and understand if you have such type of data, you have years and you have, for example, profits. It was just an assumption. Then, if someone asks you, okay, plot this for me within Python or from data analytics point of view, you will be proceeding with line plots. Now, let's start with the plotting. So you will be starting with PLT, which means matplotlib.pyplot that we already did here. Here, PLT dot plot, plot what? Plot X, plot Y, and that's it. Just plot these two. I want to have a title for this. Profit over here. Yeah? And I have to have a PLT.show. See, these are these X numbers. See, year 1, year 2, year 3, year 4, year 5. So this is how we define the years, yeah? Or months or weeks or whatever. So assume that it's a time, yeah? And these are the profits, yeah? The amount of profits. This is how a line plot shows us that when our profit went up, so we started from this first year, we started from 10,000 profits, then second year it was going up, then till third year it breaks down again, and then again it goes up. So now we are in a good side. So this is how a very simple line plot works. But we can have some modifications as well. For example, we can have saying, okay, I want to have marker. What is marker?
How the dots should be present, yeah.
So these are markers or type of data points. See, we have number 1, year 1, and this we have 10,000. So this is a data point. So these data points will be shown on the line plot. Why it is important? It is very important because it shows how many data points actually you have. Because if you have even 2 data points, it will draw a line for you. That's not a problem. Even you have 2 of them, yeah? So 2 and this 2, it will draw a line for you, yeah? But it's only based on 2 data points. Now we have only, for example, 5 data points, which is still very less, yeah? Because this is, it assumes that from first year to second year, we don't have any other data points. But if we have based on months, it would be very much accurate, yeah? So it will not be that much straight line. It will go like this, like this. So this is how showing the markers or playing different roles. So you can have different types of markers here and showing it in different ways. Another aspect of this is line style. So within line style, for example, you can have dashed line style, yeah? Instead of solid line style. Let's have it, for example, dash one. Um, Another thing which is very much important is, for example, the color option. For example, if we choose be blue, it will be coming. So different types of these functionalities are available here. So just let me show you how you will find the markers in line style, for example, because I think if you type marker, uh, see what these things are appearing here in notebook and in collab. It's very important. You have to understand how to use this. So this is actually type of this is a function, a plot function. See, call signatures. See, this is plotting x and plotting y, for example, we have here. We have right now data. So if you had a specific data set, uh, uh, you could switch that data set here, yeah? Because from the data set, for example, right now we have only x and y, yeah? But if you have a data set, for example, in our previous, here is a data set. And I want to just from this data set plot from this data set. Plot only, for example, salary with the name. Yeah, from this. So I want to have the salary, and I want to have, for example, the performance score, for example. Yeah, I want to plot these two ones. But there is my main data set. So in order to give uh, give it a command that from which data set you have to select which should be the x column and which should be the y column, the x axis and y axis. So this is how you can deal with the data as well here within the plot function. So if you don't have x and y, you can define it from a specific data set, and also you can have another function which is called, for example, data. You have to put the data where to use the data. So another thing that, for example, we can add here, this is the labels. You want to have, for example, X label. So for the X label, you can see in order to make it proper, you can have says, okay, X label is ears, yeah? And PLT dot Y label is actually the profit, yeah? USD, for example, yeah? This is how the profit is. So if you run this again, see, this is years. Because if someone doesn't understand your plot, you have to put all these labels there. That years should be appear here, and this is in which currency it is, and what is this, for example. This is profit, for example. Also, if someone wants to understand, so this is just a blank background. If you put it, for example, grid 1 and make this as a true, for example, so it brings you this type of grid mesh here, and it's because you will easily find the data points here. So this is how you can play with the different aspects of this data set. Let's assume another simple example. For example, uh, uh, this color, it was blue, yeah? And just write green, it will turn into green. Just write it, it will, so this is uh, how you can change and manipulate with the colors here. So this is how the line plot works. Now we're coming to another plot, which is called bar plot. These all functionalities you can search and understand and manipulate with these functionalities. Different type of line styles you can bring here, for example, to make your proper understanding of how you can play with the specific plot. Now coming to the bar plot. Line plot is to plot a trend over time, yeah? So you have time and you have a trend, whatever you have. So you want to just draw that and plot that. What is bar plot? Bar plot is actually used for categorical data. If you have categorical data, which I hope you now understand the type of data here. what is categorical data. Then for that, if someone asks you to plot it from visualization point of view, you have to plot it using bar plot. So for categorical values, never proceed with the line plotting. So line plotting is for trend over time. Now coming to the, for example, if we have categories, assume we have a categories of A, for example, B, C, and D. These are categories, for example. Then we have for each category values. We have values, for example, 40, 90, 70, 120. Yeah. So these are the values for each category. Now let's plot this one. So this the previous time we just put plot. If you just put plot, matplotlib assumes that it's a line plot. But if you put another type, you have to put, for example, bar plot. You have to define it here that you want to have a bar plot for that. What you want to plot, you have to plot categories, have to plot values, and assume that I want to have a color of orange, for example. And show me this plot. Name values. See, this is so this is a bar plot. Yeah. So bar plot we used previously in our data set at homework that we had. We had countries, we had number of employees, yeah, within each country. If you remember the 𝗗𝗃𝗃𝗃𝗃 assignment. So this is how bar plot works, for example. We can add more things similar like previous. We can add a title. You have to add a title all the time. For example, category values. So for example, maybe assume that we now want departments. Employees per department. Yeah, this would be the title of our what is X label? X label will be the departments. Yeah, and Y label will be, these are all the titles will be employee count or number of employees. And now assume that previously we had which type of department? We had HR, we had sales, we had engineering, and what else we had? I think another marketing, yeah? Marketing. So these were the, and assume, for example, we had there 1, 2 similar employee count numbers, but this time assume that we have, for example, this number of employees, just an assumption. Or instead of categories, let's put, for example, departments and employee count. Here again, you have to put blue. So now understand this is how you can plot a number of employees per department. So we have HR, sales, engineering, marketing. These are the departments. You have to define these labels here. The Y label is number of employees. This is the number of employees. This is from the data set. So we define here right now, but when from the data set, if you have a data set, so then you can just directly take it from the data set. This is how you can plot the bar plots. Why we're using bar plot? Because these are categorical values. These are all categorical values. See, sales, engineering, marketing, these departments, these are all categorical values. So for all these categorical values, you cannot use line plot. Yeah, so you cannot just use a line plot here and say, okay, this is how I want to plot it. For example, number of employees. Yeah, you cannot plot it like this and put. So this is how the best practice works all the time. One more thing that we have that's called scatter plot. And what is scatter plot actually? The scatter plot is useful to visualize the relationship between two variables. If we have two variables and we want to visualize the relationship between these two variables, yeah. So this is um, very important. Assume that, for example, we have a x value is a list of, for example, 5, 7, 8, 10, 11. Yeah, and we have y another list. These are numbers 12, 14, 20, 18. 1, 2, 3, 4. 1, 2, 3, 4, 5. One more. 16. We want to understand the relationship between these two lists. Are there any relationships or existing or not? In order to get understanding of relationships, we have to have a scatter plot. Scatter plot is just dotting plots. It just create plots. And for example, you have to call the pyplot library. From that, you have to call scatter, which means that I want to plot this in color. Let's put it red and see what happens. Scatter plot is actually a type of dots. See, these are the dots. It means it's a type of line plot. It's a type of line plot, but without the line. It's just dots here. Yeah. So you want to have understanding of this relationships. Yeah. So just want to know that I have these dots. Yeah, and just visualize the dots there. And then define from this scatter. Right now we have only 5, or for example, we have only 5 rows. But whenever you're working with actual data sets, you would have, for example, thousands of dots together. So just putting all those dots together uh, uh, and visualizing those dots all the time gives you a sense of trend. Is there any trend or not? For example, right now, if you see, yeah, these dots, see this one, then this one, this went up, then again. So it means you think that here is a type, it's a type of that this break-even point was this number 8. Then after that, it goes down again. So it gives you a type of understanding the the trend in the relationship between these two lists. Um, for example, we can assume it a bit. If, for example, if we have ages, let's assume that we have an age of list of ages. Yeah, for example, 30, 35, 40, and 50. Yeah, and we have a list of salaries. For example, yeah, we have 35,000. We have 45,000. We have 50,000, for example. We have 60,000, and we have 70,000. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if you just plot this one, uh, sorry, ages and salaries, and make it blue. So you see, these are the ages. Put the title properly. If you just put the title there, salary versus age, we can put X label there, age and years, yeah, and the Y label there is salary and USD, yeah. So see, this is the age, this is title of the plot, and this is the salary. These dots shows that if someone is age 25, so it gets the lowest salary. And how you make conclusion from this, you see that there is a trend existing. It means that when the age increases of the employees, the salaries will also accordingly increase. Why? It's maybe because of the experience that they're having and they're bringing to that organization. This is how the scatter plot is playing a key role in visualizations. We will be understanding these plots whenever we are dealing with the mm, actual data sets. But not right now, the main point is that you will just learn how uh, these plots are working and for which purposes we are using these plots. Now coming to the histograms. What is histograms? Histograms are used to visualize the distribution of data. We learned descriptive statistics. Within the descriptive statistics, we learned that we have to understand the distribution of data as well. So distribution of data is very important uh, to analyze the statistics within a data set. For example, we have a list of ages, yeah? And it starts, for example, from different values of ages. This is a list of ages. You want to just plot the distribution of this column. Assume that you have a column of called ages in a data set. You want to just um, understand the distribution of this column. How to do it is called plot plt.hist and ages. Now, in order to draw the histogram, you have to define what? You have to define the bins as well. What is bins? Assume that we have bins 5.
تعداد مستطیلایی که
Yeah. This is types of, you see, these are bins called 1, 2, 3, 4, 5. So these are the bins. We divided the age column, Yeah, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are 13 data points. We divided 13 data points into 5 categories. We want to see which category of age are existing in our data set. You know what I'm saying? You have a long list of people in your data set, but categorically dividing them into 5 categories. How you will do that? You will be using histogram. This histogram shows that majority of my people within this data set are between the ages of 20 and 30. Between ages of 30 and 40, I have the lowest number of people. Between ages of 40, 50, and for example, so you see this is the ages maybe 45, yeah? So in 55 to 60, I have the similar number of people here. So this is how you're dividing actually a long list of ages into different categories, and you can name all these categories different names. Each bin that you are saying, for example, I put 3 bins, yeah? You can just put it 3 bins, not 5, just 3. Still see, age 20 to 35 has the highest number of people. So make it more, for example, uh, accurate. You see, if you, within 5, if you have 5 categories, data says that between 20 and 30 has the highest number. But if you just divide it into 7, so you disperse the categories. Now see, this is different categories now you have. So those 2 categories which has been accumulated previously, now they are side by side. So between 20 to 30, between 30 to, assume just 32, 35, for example. So you have this number for each category, different number of people having. This is how histogram works. And one more thing which plays a key role in this histogram is the age color, because in order to get the proper understanding of the bins, you have to put an age color in a different way that you will be having a proper understanding of uh, the data set. And this is now not a bad data set, that you have a proper understanding of ages and bins, and we divided the age categories. So now if someone asks me within my data set, okay, you have huge number of people within your data set, how your data set looks like, I will say, okay, yeah, majority of my people within the data set are between the ages of 20 to 30. So hold on, see, this is how gives you the distribution of data. This is called distribution of data. Histograms all the time gives you the distribution of the data. So we will be putting, for example, title for this all the time, age distribution, distribution, and plt.x label all the time, age plt.y label all the time is frequency. Yeah? This is frequency, or actually the number of. This is the number of. So we have 4 people below age 30. We have only 1 person between 30 and 35. See, this is 30, 35. Yeah, 30 and 35. Maybe not more than 30. Only 30 is one guy, then automatically 35. But below 30, we have 22, 25, 29, 30. See, 30 is also included there. Yeah. So within this between 40 and 30, we have only one guy. See, this is only one guy. Then we have 40, 41, 42. See, to tell how many people we have, 3. Yeah. So this is actually 48. See, this is age 48. Yes. So we have 1, 2, 3 here. So this is the 3 here. See, this is how it gives you the distribution of. This is called histogram. Well, it's one of the very major, very important things from for the understanding of the data. So similar, for example, if we have instead of ages that we had, yeah, if we have performance score. Previously, we had performance score, yeah, we had performance scores for 5. It was just 5 of them, yeah. But right now, if we have performance scores for thousands of uh, employees, now we cannot just go and say, okay, how the performance is there. So how you will have an understanding of performance? You will not go by thousands of employees, by each one of them. You will just, whenever you want to present the data, you cannot present the list of those thousands people. Yeah, you have to present a categories. For example, if I had thousands of these numbers, for example, if you just increase whatever 88, 99, um, 78, 66, for example, 55, 54, 35, 20, 33, 29, yeah? Uh, just assume huge number of. Still, if I want to present the data to someone, I cannot show them this list, yeah? This is why visualizations come in. This is, I have to present them. This is how the age distribution looks like in my organization, for example. And this distribution shows me how much employees, hopefully, gives me an understanding. Majority of employees are younger or older. So this is how, whenever, assume that this is performance score of employees, thousands of hundreds of employees. Still, if you just present it in that way, it gives you a sense how much employees, for example, performing well, how much employees are performing not well, for example, yeah, so worse. So this is how um, histogram is important, gives you understanding of the distribution of the data. Uh, let's go to the pie chart and see what is pie chart actually. Pie chart is useful when you're showing percentage or proportion of categories. Yeah. For example, we had this department engineering. Yeah. This was a bar chart, type of bar chart. Everyone is clearly understands here that okay, how many employees were in HR, specific how many. Yeah. But if someone tells you, okay, I don't want to just understand how many of them, but I want to have understanding of, for example, percentage of them. So for percentage of them, or just if you're not percentage within bar chart, you also can show percentage of that. But one more thing which is very much important, if you want to show something from a whole, a portion of a whole, for example, here in bar chart, it's very difficult to understand. For example, yeah, from this bar chart, you can directly understand HR has the lowest number of employees, marketing has the highest number of employees. Yeah, that's it. How many total employees are there? How much percentage of those employees are in marketing? How many are in engineering? How much percentage within sales? So first giving a whole picture, then a portion of it. Within the bar chart, it's not possible. It is possible with lots of modifications. But there is another chart that everyone is used that's called pie chart. Pie chart is another type of chart. It shows percentage, proportion of categories. So as a whole, just like assume the same thing, departments and employee count. Yeah, departments and employee count. So we have departments and we have employee count. Now let's say instead of bar chart, I want to plot it as a pie. Yeah, what I want to employee count. And here, for example, within the um, within the within the pie chart, there is no need that you have to define two variables. Previously, we had two variables. We have departments and we have employee count. So for bar chart, you have to first define the categories, then the number of categories. Yeah. So department per categories, and employee count was number of categories. Yeah. So these are the categories. This is number of categories. For pie chart, you will be just focusing on the if even it's category or not category, but on the numbers side, which is the count of employee. We will just put in that. Then we will be saying, okay, even if you don't put show, it will generate the file for you, not a problem. But if you have show, then those other information. So this is how it looks like. So these numbers, so all of them have been happened in a circle. Then these numbers are divided from them. So now you have to have labels here to understand what are they, yeah? What are the labels here? Departments, yeah? Departments are already there. So this is departments. You have to define the labels. Now you understand. See, this is sales, this is marketing, this is engineering, this is HR. Good. Okay, still you want to have the percentage, yeah? You want to know how much percentage of that. So you can do the what is called auto percentage, yeah? Just auto percentage. How it should look like? First of all, auto percentage, it should be look like what? Of a percentage, for example, 1.1 if. Now see what it means. You will be having one decimal point and then showing the percentage at the end as well. So this is how this auto percentage means. It means instead of just showing 28%, you can have one more decimal point there. And at the end of this number, also show the percentage for them. This is the way that you have to define the percentage. It shows that only one decimal point. If this is, let's assume that this is 0. Yeah, see, this is 0 now. If you put 2 here, it means 2 decimal points. This is the percentage portion. And this additional percentage means that showing this percentage end of this as well. So this is how you can show the play with the pie charts. One more thing, it's called start angle. Yeah, start angle. If it's 90, look. So how it is from this. So it goes like this. See, the highest will be starting from this, then going. So this is how start angle works. Like now you have the largest here, then here. So starting from the 90 degree, the circle, calculating from the 90 degree. If you can change this degree as well, whatever degree you want, but this is how some of the things that you can play with the pie chart. The title for this we can put all the time. We have to employees per department, yeah, or employee distribution, because it's actually distribution. It shows the percentage, yeah? This is called pie chart. Now coming to another chart, which is called area chart. And what is that actually? And why it is important? Area chart is actually useful for representing cumulative totals over time or any other continuous data. So for example, if you have cumulative totals and you want to show it over time, so instead of line, it's a modification of line plot, but we will see it right now in actual how it looks like. For example, just assume we have the data of line plot. Hit on this one, copy, bring it back here. This is if you want to put an area plot, it's a modification of line plot. How to do that? For example, you can just put plot, you say X, Y, and you say, okay, color for this will be light blue. See what is light blue, okay? I will all the time. So this is how the line plot is, yeah? A previous line plot that we have drawn. Good. Now, in order to make it to a line plot, just convert it to a line plot, you can have PLT dot fill between X and Y with which color? For example, sky blue. This is now a line plot. See? What does this line plot shows? It just colored the area under each of them. This is type of area for each proportion that you have. So this shows the cumulative total for this, for example. One more thing here you can use, for example, alpha. Alpha shows, for example, if you have alpha 0.4, so it is now, it's a bit, the highest alpha, the original color will appear. The lowest alpha, the color will be less shaded. For example, if you have it 9, so this sky blue will be very relevant to sky blue. But if you have just 0.5, it means only half of this sky blue will be shaded here. This is how the area chart works. Area chart is, you will see that, okay, why this area chart is important. Area chart is one of the important charts whenever you are having two line plots. If you have two plots and you are just plotting two line plots into one, then area charts are playing a key role. This is one thing. Another thing, whenever you're going to the statistics, sometimes you need the area under this line, for example. This area. This area is sometimes playing a key role whenever you are doing probabilities, and within the statistics, we will be coming to that. So this is why one of this other modification of line plot is called area chart. Just to show you how you will draw it, and that's it. And nothing else here. It is just a modification of line plot. This is how the area plot works. Now coming to another plot, which is one of the important plots from descriptive points of view, it's called box plot. Box plot is very important whenever you are doing descriptive statistics. Box plot shows that this the distribution of data based on a 5-number summary. And they're very useful for identifying outliers. You know, so we will be doing the same thing with our age. This plot that we had here, this is ages. Copy. Just bring the ages and plot, box plot, and ages. PLC. It shows the distribution of the column ages, but with very different another type of aspects of data. You know why these are very important aspects of data. This is called whisker plot as well, but we are calling it box plot. It shows the highest number here, for example. This is the highest number, see? Around 90. We had 88, see? This is 88. So this is the lowest number, yeah? The lowest number was 22. See, this is 20, it's 22. This box shows actually that the majority of data is, it means this is 25%, this is 75%. So this is 25% and this is 75%. So this 50% of data is between age 30, around 35, yeah? So just assume that from this between 35 and between 60. This is how the hair in distribution plot, you cannot say this assume this one. You just divided the age into different bins, yeah? These are the different bins. Bin 1, bin 2, bin 3. So these are the bins, and each bin you can have a name for it, yeah? For example, assume if you don't have ages, and this was income, yeah? Income of different peoples. You could have different bins for the income level. And then you will say, okay, who is low income, who is mid income, who is high income, who is different. So you could have different bins for that. Here also, you can have bins of, for example, for ages, very young, for example, young, mid ages, for example, senior ones, and senior citizens, and higher than that, or retired ones. Yeah. So this is how you can have different bins. This gives you an overview distribution of age. But this box plot shows that what is the minimum of data, what is the maximum of data, what is the mean average of data, what is the 75%, and what is the 25%. It is actually exactly the same thing that we have done previously when we called descriptive statistics. Here, I called describe. Do you remember yesterday? This describe. This was the mean, 25%, 50%, 75% maximum. Min, 25, 50, 75 maximum. This is box plot. So this descriptive statistics from data set, this is actually the box plot. This is min, 25%, 75%, 25%, 50%, 75%. This is max. You got it how the box plots are playing a key role in why they are very much important. So we will be all the time using this box plots. We'll see we have only y level here, and that is age years. Yeah? This is the box plot. We just learned it yesterday with the numbers. Now there is another thing called heat map. Heat map is interesting. It shows the relationship between two variables. And that relationship is actually shown by the number of, for example, how to show that? By the number of, by the intensity of color. So this is one of the good visualization aspects if you want to show that with the color intensity. For example, just in order to create, let's create a heat map, for example. Let's create some data first of all. Please mute yourself. Yes, please mute yourself all the time. And okay, now np random dot rand and in 10. What will generate this thing? Who can tell me?
Would it generate random data, Professor?
Yeah, it's true. It's very obvious because there is a, a word random data, yeah. but actually a bit more specific.
Maybe it generates like 10 by 10 row and columns.
Good.
The random
So
data.
exactly, that's random data. But see, it generates an array of data. See, from 10, starting, for example, from 0 to 10 with the step of 10, yeah? So we studied this previously, yeah? So this starts from 0.1, for example, and it goes to the 0.1, which is actually the number 1. So this is how it generates a random data. We also generated another type of this random data. So who can tell me what was another function here?
Rand-int.
Rand-int. Yeah, and what was the difference between that?
It will generate integer data
Exactly.
point.
Oh, sorry. So now just assume that we generated some data. This is a data, yeah? Data set, columns and rows, yeah? That's it. We have 10 columns, 10 rows, yeah? And that's it. See? Don't miss it. This is actually 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See this square one? It starts from here and here because it doesn't go like this, yeah? It just automatically gets to the second line. So this is actually 10 by 10. So you have to be sure that what you have said at the beginning. It just shows like this. It's 10. And this one is also 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See? These are all ones. So 10 by 10 with random data, but with just between 0 and 1 it generates, but with the floating data, not the integer ones. Now let's assume that we have created such a matrix of an array of 10 by 10 with the random data. And let's see how the relationship between, assume that this is the X and this is the Y, yeah? What will be the relationship between them? Just say that we generated this data, and interpolation is very important here, yeah? So we will be calling about the nearest one. PLT all the time if you use so. So see, this is a 10 by 10 plot, but it shows the relationship between points using the color intensity. So you can change the color with this function as well. If you put it hot, it will just change it to another type of color. So the darkest one has the highest relationship. What does it mean? This point has the highest relationship between each other. For example, the lowest one, the lightest one. It means it has the lowest relationship between each other. So this is how you can just play with the heat map. If you just put a title for it as well, heat map example, and we have to one very important thing that here is the color bar. You have to have the color bar. Oh, that's vice versa. See, if the relationship is 0.2, so it's darker. If the relationship is the highest, it's lighter. So it means 0.2, or this is the lowest relationship, this is the highest relationship. Now just assume that we don't have the CMAP. Let it make standard. It's the same thing, yeah? Dark color, no relationship. Light color, highest relationship. Now let's see. 0, here is 0, yeah? With specific the 0 amount, which I understand that there is no 0 specific 0, but there were lots of floating numbers. But these two are having actually the the medium relationship between each other. If you just assume, for example, this square has the highest relationship between each other. The square is which is larger than 8 and larger than 4.5, 8.5 and 4.5. These ones have the highest relationship between each other. So from this heat map, if you have two columns, right now we don't have two columns, we just generated some data, random data. But if you have 10, you have specific columns, you want to see how the relationships are there. For example, we had this column here, see these dots, yeah? So the scatter plot is also showing the relationship between the dots. Are there any relationships existing or not existing? It shows, yeah, there is an increasing trend or relationship existing as well. This heat map is also showing it based on the color. Uh, and the two variables or based on the intensity of color are related or not related. When we are doing machine learning model, this heat map will be one of the very interesting plots there. Because for machine learning, if you have lots of columns, yeah, there and lots of rows there, and you want to know, okay, for example, I have a column, different types of columns, but I want to predict age, yeah, for 1,000 students. I have 1,000 students in a data set, and I have a different, for example, 20 columns and features. One of them is age. For age, I want to predict, for example, uh, I want to develop a model to predict the age. For that, how to do that? Now, first, in order to which feature is very much nearest, closest to the age column from a relationship point of view, you have to define those features. If you're not defining, if you're in a machine learning model, you're defining a feature which is very far away, doesn't have any relevance to the targeted feature for which you're doing the prediction, then your model is not accurate and gives you inaccurate results. This is why heat map is, for the feature importance, it's important to understand the feature importance, first of all. We have another plot, it's called stacked bar plot. You will not be using it too much, but it presents multiple series for comparison. You have, for example,
Professor, sorry, can you explain the heat map a little bit with a real-time example? Because I did not understand where we use it.
sure, I will be explaining it with a real-time example. Just let
Okay.
me proceed with the stack bar plot. I'll be completing this session. Then I will be coming back to what everyone. I will be coming back to all the questions. For the stack bar plot, for example, assume that we have departments, yeah, similar departments that we had, yeah, and we have employee count. Employee count, for example, for current year, yeah, and we had employee count for last year. And what happened there? We had 20 there. We had 17, and we had, for example, 60, and we have 90. So now, if we have one categorical value with two numerical values, it means I have engineering department, and I have categorical values of departments, and I have count of values. But count of values, I have two types of count of values. One is for current year, another is for last year. If I have it for current year, yeah, what I have done for current year, I did it like this, yeah. So I show it, okay, this is now the distribution of employees per department. Or I show it in a bar chart. This is how the employees department. But if I have two of them for this year and for the last year, so how to show it? How to actually put it in a one visualization for comparison. So let's define that, okay, I have plt.bar, which is the similar that we have. We have departments, yeah, and we have, for example, employee count current year, and make the color, for example, orange. Now put plt.bar again, departments, employee count last year. One more thing which you have to put here, it's called a function called the bottom function. What will be the bottom function for this? It will be the employee count of current year, which is the first row, this row. And put the color for this, for example, assume that it's blue, yeah? What it says a PLT bar, it's a bar chart of departments. These are departments. And I have employee of current year, color orange. These are the employees of this year, current year. See, these orange ones of current year employees. And I have another bar chart, which is the employees of last year, which shows these blue ones. These are the employees of last year. And bottom of it, it means so to the bottom of this blue one, there should be the orange one, yeah? So this is how you define the stack bar chart. Stack bar chart, this means, okay, this from all the employees within marketing department. This matches from last year and this matches from current year. It means current year, the employees are getting higher. So you see, this is how you're just showing how the stack bar chart gives you a comparison of different values within a specific category. So within engineering department, for example, I have this much employees. This is the whole number of employees. This is 125 employees. It is the 100% of all employees within the engineering department. This matches, see, this matches. Around maybe 70 of them is from current year. See, this is 70 of them is from current year, and 60 of them is from the last year. So this is from the last year. So this is the current year. Or vice versa. You can put this top or this bottom. So you can put the last year and current year different types. HR, for example, this year they have this is the whole number of employees. This matches from last year. This is from current year. This is how it calls stack bar plot. If you have one categorical value with two numerical representation, and you want to compare them in a chart, that's called stack bar plot. One of the plots which are very much interesting, but everyone is sometimes they are using it because it shows a good thing. I will not demonstrate it here for you because I will just ignore that. That's called violin plot. Violin plot is actually a type of box plot. It is actually similar to box plot, but it's type of another way of showing it. But we will be just I will just put it here the name. But personally, I will not use it. It's because that I really don't know its difference between box plus and violin. However, there is difference existing there. It shows also the density, but the thing is that mathematically or statistically, it doesn't add any value to the visualization. So this violin plot is not actually within the matplotlib. You have to call another library, which is called the 𝗔𝗿𝘃 library. And for that 𝗔𝗿𝘃, you have to first, we will be learning 𝗔𝗿𝘃 as well. Import 𝗔𝗿𝘃 as Linux. This is a similar library like matplotlib, but it has this violin plot. So if you just call violin plot and ages, and then say, okay, _pt.show, it gives you the same box plot, but with different way of showing it. See, this shows also the density. So in box plot, you have the same thing here in box plot. So this is a violin plot. This is type of, in box plot, you also have a proper understanding. Yes, that the majority, the 50% of the data is within this area. And that violin plot is actually showing it in another way of how to do it. So this is how you're using different the same thing of box plot, but with density to understand proper understanding of how it's working. Now coming to the customization of some plots, for example, you have to understand, for example, some customizations for the some customizations, which are not that much. For example, if we have this salary, yeah, here is salary. Not this box, yeah. If we say, okay, we have months, instead of, for example, 1, 2, 3, 4, 5 months, let's assume that we have, for example, January, Feb, and March, April, May, and June. And we have sales. We have 10,000, we have 20,000, and then, or just assume it, make it less than that. 100, for example, 150, 200, 170, 250, and for example, 300. 1, 2, 3, 4, 5, 6. So these are the months and these are the sales. We did a plot, for example, of this line plot, yeah? Line plot of months, of sales. We used the marker, yeah? You see the marker should be like O. We used the line style, should be, for example, dashed line style. We use the color, should be green. We use, for example, one more thing here, if you want to add. Line width 2 and marker size. And these two are additions. Now see what additions happened. What additions happened? This line width, previously it was 1. By default, it is 1. We put it 2. It increased the width of this main line. Marker size, these are the markers. We put it 2, just assume that it's too much, just put it 5. But these are some modifications that we can bring into the line plots. We had plot.title. it was monthly sales, for example, trend, yeah? But within this title, you can have another function called font size. You can change the font size to, for example, what happened again? Font size without H. See, this is monthly sales trend. If you just put a 10 font size, this is the lower number. If you put it 16 or just 14 maybe, that would be sufficient. This is how you will work with the we had plt.grid previously. We said, yeah, let it be, the grid should be there. These are the grids, but let's modify that. The line style for the grid, let's make it, for example, 2 dotted lines. And the line width, make it, for example, 0.5 instead of 1. So you see, you just change the line width. Now it looks like better, yeah?
Sorry, sir. Instead of double underscore or double dash, we can use just colon, so that we could get the dot line style.
Not dot, and just this is this type of lines I want dashed lines.
Okay.
Yeah. For the we will having legend using legend as well. For example, you just put legend. What should be in the legend? Assume that in the legend you want to have sales, yeah? This shows that sales is type of sales, yeah? Sales January, February, March, April, May, June, and this is how the sales happening. But sales is automatically to the upper left side, yeah? You can just change it. It's now automatically in upper left side, but you can change it in the location, you can change it to different size. You can just change it to upper right here, see? This is middle right is also, not middle right is not working. Without upper left, this is the location of legend in different positions, it shows you. But whenever you're calling the location, you will have a different ways of doing it. And there is another function as well called annotate. I will be not going through the annotate right now, but I will be coming to annotate when we are doing the data visualization, because lots of these things we will be learning next week as well. One of the very much important points here is this is just showing you different ways of understanding the customization of plots. You can customize each aspect of this plot, whatever you want. So this is how the good thing about Python is there. And lots of things, you can just go online and understand all these functionalities here. There are lots of functionalities. Whenever you're just calling PLT, for example, PLT.grade, and then lots of other possible values. See, these are parameters. All these parameters are existing within this only method. For example, see the grade. You can within the grade you can have the color, you can have the line style, you can have the line width. See, these are all the valid arguments. Different types of properties you can put for this tab style, for example, join style. See, I mean, whatever you want, you can just do through these documentations. Fill style, for example, the grid. You can have a grid with a fill style. full fill, left fill, right fill, bottom fill, different types of filling style. Yeah. So line styles. See, these are all the line styles. 1 dash, 2 dash, semicolons, offset or on-off sequences. These are all the things that you can just take it. Look at the marker size. Yeah, so marker size. You can have it in different ones, different types of marker size here. These are all the functionalities within this grid function, if you call it, for example, this grid which I just called it. Yeah. Similar, for example, in legend, if you just put plt dot legend, so automatically see, so different things happens. Yeah. So automatic detection of elements, for example, here you can have labels for the legend. You can just define a new legend here automatically from a list there. You can set a level for the legend automatically. This is that line 1, line 2, line 3, and for each line, for example, you don't want to put it sales. Yeah. So for sales, you want to have another label. You can do that, for example. See, this is how they're just putting different labels there. These are the parameters within the legend function and that legend method it gives which type of parameters it accepts. It uses labels other parameters. You can have legend log. See, this is I used upper left and upper right. Yeah. And lower left. See, lower right. Also upper center. I put previously middle. Yeah. So middle is not working with matplot. It's working with Seaburn. See, upper center, lower center, center left, center right, different types of functionalities that you have for this legend. It appears here. You can have it and understand it and input it whatever you want, and it's feasible for you. I hope you got all the customizations here. This is the good thing about Python. So just see some subplots. If, for example, it's useful to create multiple plots in a single figure. Yeah. So, for example, if we have x of for example, a list of 1, 2, 3, for example, 4 and 5, and then we have a y1 of, for example, 10, 20, 14, 50. This is the list 1. And we have, for example, y2, similar, for example, 15, 18, 25, 30, 35. So these are 1x and 2. So in order to plot two plots in one figure, so right now we have one plot in one figure. Yeah. If you have two plots in one figure, you can define the figure function within the matplot, and you can define the figure size, how much the figure size should be. It should be, for example, 10 by 5. This is the list of the size of the figure. So now let's define the first subplot here. Assume that we want the first subplot. Now, instead of plot, you can just put subplot. Yeah. Subplot is 1 to 1, and what should be within that subplot? There will be x, y, 1. Marker will be, for example, this, in color will be blue. Assuming this will be the title for this will be, for example, title line plot 1. Now for the second subplot, you will have plt subplot. What this 1, 2, and 2 means? This is the coordinates within the figure. It means I have subplot at a coordinate of 1, 2, and 1. So the first one will be the first subplot, and the second one, now plot me something else. Plot for me x and y2. Marker in this plot, I will use, for example, S marker, and the color I will be using red, for example. The title for this I will put as line plot 2. Now PLT, in order to show them, you have to say, okay, site layout. Site layout means that whatever we put it together. Now show me how you will plot this one. This is not tight plot. See, now we have two plots in one figure. This is row 1. This is the row, and this is the column. Row and column. So I have one row and two columns. This is the general shape of my subplot. I have one row and two columns. Now, within this shape, in the first row, in the first position, in the first column, draw me this plot, and the second one, draw me another plot. This is how the subplot coordination works. If you have, for example, 2 and 2, it means 2 rows. You will be having 2 rows and 2 columns. Then you will define 1, 2, 3, 4. So like this. So you will be having different numbers within that figure size. This is now 10 by 10. If you have just 10 by 5, you just figure size will be smaller. See, this is now 5 by smaller size of figures you can have. This is the general type of figure. So this is how it gives you that this is the whole figure size. Then you divided the figure size into one row and two columns, one row and two columns. Then in the first row, you wanted line plot 1, in the second row, line plot 2. This is how you can have different plots within figures, within different figures. This is our understanding. So from our data sets and what we have done. So just do some examples. I really don't know if df is still there. No, df is not defined. See, we don't have df right now. We have to run pandas again, and I really don't know my no, drivers there already counted, but I have to run this one, I think. Yeah. If I run this df now, df should appear here. Yes, we have df here. See, performance score, job satisfaction, everything is there. So this is the df is there already. Let's do some plots that we did. For example, let's do some bar plot. Yeah. From this df, I want to have all these names. See, this employee name. This employee name, I want to have it as a x-axis, and their salaries. The salaries, I want to put it as a y. The color, let's have it plt.show. See what happens. James Wilson, Marie Garcia, Robert Brown, Emily David. These are all the categorical values from employee name. So from this column. and then their relevant salaries. This is the salary of first guy, this is the salary of second guy. This is how the salaries of different people, for example, works. For example, if you just, instead of department name, for example, these are the employee name and their salaries, for example. Yeah. So this is how we can have a bar plot. We have to have a title, proper title for it, because it should salary by employee. We have to have the X label for it. X label could be, for example, employee name, and PLT, the Y label, it should be salary and USD. Okay, so you see these names are not showing very well here. How to do with it? What to do with this?
Maybe we can decrease the number of pins.
No?
You can, I think you can change the direction.
Great. How to do that?
The direction should be 90-degree down, up.
Yeah. Tell me the whole thing, how to do that?
I don't know exactly in Python how to do that.
Okay. So you're right. So this direction should be 90 degrees or 45 degrees, yeah? So if we just these are text, yeah, X text, and we just call the rotation 90 degree. So these are all rotated to 90 degree or 45 degree. So it will be just rotated to 45 degree. So these are texts. See, these are all X texts. So these are the tick marks within the X. You just change the direction of it. See, this is how it works. Now let's see, for example, if we have count of departments, yeah? Not count of departments, for example, we have engineering, sales, HR, so these are all good. Performance score is good. Count of let's do something else, for example. Gender portion, yeah? So gender count. From this div that we have gender. We can say value counts. What does it show for me? This gender count. Gender count show that we have 3 males and 2 females. Yeah, this is how the value counts on overall data set that we have. Now, good. Let's put this as a pie chart and say that we have gender count. Labels for the gender count is gender count dot index. You can add it. Auto percentage, auto practice actually similar percentage 1.1 percentage 1 decimal sorry 1 decimal with the percentage and just I think see what it happens. Gender count
Labels is wrong. Labels.
Labels is right. Why?
The
I just
auto
want
percentage
No,
is
quotation.
this auto percentage. Label is right. Okay. Now I will tell you why the label is right. Previously we had a label column, yeah? In this column what I said. In this column, look what I have done. If you call gender count, yeah? This is gender, yeah? Male, female. This is count. This is the index of this data frame. This male and female is the index of this data frame. I said that take the labels from the index of this data frame. I have gender count. This is my data frame. Whatever is in the index, put it as a label. These are the indexes here. So they just put the index here. Now, see, we understand that we have 60% male and 40% female employees. And if we have a start angle again as 90%, so it shows you like this. See, starting from this side. So 40% is female and 60% is the male. So this is how the distribution of employees. So PLT.title, distribution of employees by gender. And one more thing, we can have, for example, we can have PLT.scatterplot what of df performance score and let's salary. Yeah? Let's see performance score and df salary. Well, let's say below. This is the scatter plot between it shows the relationship between the performance score and between the salary. You see, there is no relationship actually between, you cannot say, yeah, that there is a relationship existing between the lines are not increasing, lines are not decreasing. For example, someone with the 85, almost 85 number of performance score is having the lowest salary here. And someone with the very lowest job performance score has the highest salary here. See? So there is no relationship actually from this scatter plot, but this scatter plot all the time give you an overview of what's happening there. So it means there is no relationship between the salary and between the performance score as well, but it gives you another sense as well. Yeah, sense is actually that, okay, if someone is not performing well, then why he should get this much salary here? Yeah, this guy is getting almost 72,000 US dollars in performances here. So this is how you're gaining wisdom from your data. This is why scatter plots or all these visualizations are important. Someone is performing very good, around 85, but has the lowest salary here. See, this is 50,000. This guy is very good guy. He's highest performance score and highest salary. That's very brilliant. Yeah, that's the ideal case. But this case, lowest salary, median performance, and highest salary, the lowest performance. These are two extreme dots that has to be addressed. See, this is how visualization bring you new wisdom and understanding from the performance versus salary. X label is performance or Y label is salary in USD. Again and again and again. See the American English. All the time you have to put label. So this is how scatter plots playing a key role together with them from. Now, I hope you had a proper understanding of what's going on. Uh, um, and what happened, and also examine some of plots from our data set.
Sir, I have a question regarding this plot.
Yes, please.
For example, as we see on the y-axis, we have the salary, right? Is there any way that we can put a comma for this value, like 75 comma in terms of like 75,000? There's a comma there.
Yeah, lots of modifications you can bring. Yeah, you can put USD there as well. You can change all those things. So it's all part of visualizations. It will be coming later on, step by step. We will be coming to that. So whatever is there, I'm just saying, whatever is there, you can manipulate that. You can change that. You can put these separation lines here. You can change even this USD, which I wrote it here. You can put it here automatically. You can just put it, divide this 75 by 1000, just show 75. Then here you can just put K that shows that this is 1000. Whatever type of manipulation you want, you can bring to these plots. That's part of data visualization. We will be coming back to it next week, because the aspect of visualization is now you know the basics of how to visualize something, but where to put the title, how to visualize this one, how to put these one properly, how should be the aspect ratio of all these things is part of data visualization. It happens uh, next week and during our visualization course. Now, one of the students asked me that right now that he doesn't get the heat map. So let me define for you, for example, right now the heat map. Yeah, we have this uh, DF. Yeah, what is the DF? DF, we have employee name, sales, salary, performance score, and job satisfaction. Okay, so we have 1, 2, 3, 4, 5. So let's assume that for this div, what is missing is actually the age column. Yeah, so we don't have the age column for it. So assume that age is there and 25, 13, 45, and so 1, 2, 3. Now we have a new column called age as well, yeah? So we have 25, we have 30, we have 45, we have 50, we have 40. So these are the age columns as well, yeah? So we just added this age column to this data frame as well. Now let's assume that we want to create a matrix from this data set. What is the matrix? Matrix is actually defining the correlation between all those numerical values. We have salary, we have performance score, we have job satisfaction, we have age. These are all numerical values. In order to find the correlation between these numerical values in this data set, it's very easy. It's very easy. Then just say the correlation matrix between all numerical values. If you just call this df dot co rr, okay, we have to, for this, it assumes that this is a if one is actually if salary performance score job satisfaction age. Now what is df1? So this is the df1, yeah. df1 knows all these numerical values. So just assume correlation matrix is actually df1 correlation matrix. Good. We calculated the correlation matrix for this df1 portion. We just got the salary, performance score, job satisfaction age, all these numbers. Previously, we had an error here, so it's mix of integers and numbers, so this is why it gets all the time error. In order to create a proper correlation matrix, we just extracted these relevant columns from this data set. Correlation factor all the time works with the numerical values. So we have to have proper numerical values here. Now we have correlation matrix here. Let's assume that we want to create a heat map for it. See, this is salary, this is performance score, this is job satisfaction, this is age. The light number means the highest correlation. The darker color means the lowest correlation. Now see, salary with salary has the highest correlation. It should have, yeah? So salary, it should has the highest. So this is very obvious. Salary with performance score, see? It has the highest correlation. It means salary with the, from this dot, we saw that only 2 of them were wrong, yeah? 3 of them were right. So it means from 3 of them, it means there is a correlation between the salary and performance score. So this correlation is existing. It doesn't mean that this correlation is existing. Actually, you know that there's one is existence of correlation and another is how the correlation exists. It is a negative correlation. It's a positive correlation. So it's affecting vice versa. How it's now we will be coming to the. There are 2 things that we should not mix it. One is causation, and one is the correlation. So it means it's not the cause of the issue. It means performance score is not the cause of salary, but there is a correlation exists between them. So causation is something totally different. We will be learning that during our statistics course. That what's causation and what's correlation. Statistically, there is a slight correlation between job satisfaction and between performance score is also existing, a bit lighter than this one. There is a correlation between some type in this way. See, this is type of 0.4, 0.5, 50% type of correlation exists between age and between salary. See, but between age and other factors, there is zero correlation. Job satisfaction is totally not relevant, for example, with the age. Performance score is totally not relevant with the age. So how you draw things from this correlation? You see that there is a correlation between salary, performance score, job satisfaction, and performance score, job satisfaction and salary. So this is how there is a correlation exists between these two, but there is no correlation between job satisfaction and age. So if you want to predict, for example, age from this, as I mentioned previously, if I want to predict age for this data set, I will never use job satisfaction and performance score as features because there is no correlation exists between them. I will use salary only as a predicting feature for this data set. If I want to predict salary, for example, from this data set and during my machine learning model, which will be coming back later on to that, I will never use, for example, for the salary column that we have. Here is the salary column. See, I will not use, for example, this one, this performance score. Performance score is a bit here, yeah? So this has a very slight correlation with the salary. But age, for example, here, see, it's having, age has a, age in job satisfaction has a highest correlation with that. So I will choose that, for example. If you want to predict performance score, I will see which other factors having a high correlation with it. With the performance score, for example, this is performance score, yeah? With the performance score, what is having the highest correlation with that? Job satisfaction has the highest correlation with that in salary somehow. See, here is the salary. So for the for the performance score, job satisfaction in salary, they have the correlation there. But performance score, they should have all the time 100% correlation. This is very obvious. If I want to predict job satisfaction, I will never choose age for that as a prediction, as a feature to predict it, because there is no correlation between age and job satisfaction. But there is correlation between job satisfaction and performance score and between salary. So I will choose that. I hope I respond to how the heat map works and how you will interpret the heat map with a real example of how you will dealing with that. So see, this is why whenever you're doing correlation, predictive modeling, predictive analytics, you have to understand, for example, for salary, what are the important measures for salary that I have to keep in consideration? For salary prediction, all the time, I will keep into consideration, for example, the age. See, the age will be the first, then the job satisfaction will be the second, and performance score will be the third. So from 1, 2, and 3, so consequently, the way of how we will be dealing with that. This is how heat map works. I hope you got it, and I'll be coming now to questions and see what is there. So, are there any specific questions? Please, Umaid Askari.
Thank you, sir. I have a question about the names of the colors when we're using the colors in different charts or in different visualizations. So, as you know, that it's very hard to memorize the names of all colors. And is there any thing, or is there any way to use these to use the proper name for the colors?
Yeah, I just showed you previously. See, I just showed you here. I demonstrated. I think you were not there. So you see what? For example, I just showed here. Yeah, you just type this one, So the standard parameters of all this grid line, whatever is there, it appears here, for example. And it gives you the whole understanding of what is there in which type of functionalities within that you can use. See, line styles, for example. These are all types of line styles you can use, for example. Yeah, different types of colors you can use. You can go to the this was just a example how you will dive deep into the for example uh, um, into the functionals and properties of the different uh, uh, methods in charts deeper and deeper. So this is how the value works, how these plots are calculated, and all those functionalities are within this plot is existing. For example, the text one, see the auto percentage one. All of these are somehow existing in these documentations here. You can just have a look at it and understand it, or if you just, for example, see the legend one, the shadow one, the degrees, how you the start angle. Yeah, so we just use that start angle there. Different things are here. You can just go there, and so we have auto percentage. Yeah, auto percentage. How is this percentage distance? Another thing that we didn't use that, but you can use that. Different things you can just see and use that from different documentations. If you go through all those ones, it will be very difficult to cover all those aspects of that. But when we are working, practicing, so we will be practicing that one by one. But for more detailed documentations, you can just go to the python.org documentation, which I showed you at the beginning, or W3 School, which I demonstrated that I was using that previously. Ali Sirat, if you have any questions more.
Thank you very much, sir. I have some three questions. Maybe we will study in visualization. So before that, I would like to ask you if you bring those in your teaching. For example, how to show the significance between the bar plot, for example, which one is significance. So the significance should be shown, for example, by writing A, B or C, something like that, or like a star. And also we need to have a bar, like standard deviation bar on the bar plot. So that also may be needed in the future. So if you have in your visualization. Similarly, I would like to ask you to add like different color. So for example, I would like to have the significant one in blue color and the control one in red color. So that one would be interesting. Thank you very much.
Yeah, thank you. Thank you. When we are going to study the statistics and data visualization, then we will be having all these ones one by one. Thank you. Any questions?
Thank you very much.
Classical masalah agad nafhmید. So officially the lecture is concluded here. So اگه کسی میخواد چیز را بدری بفهمه پشتو بفهمه یا نفهمیدم از مطلب من میتونم سوال کنم بهش تشریح بدم. Yes, Ashley?
Sir, yeah, I just want to ask, during this coming week, will we have one assignment or a short assessment after the session, maybe?
For this week, we will be having an assignment, but that assignment will not be just for the next week. The deadline for that assignment will be the other week. It will also cover the visualization portion as well.
Okay, thank you so much,
I will be
sir.
sharing within this week the assignment, but the deadline for the assignment will not be the next week, because next week we have to add the data visualization portion there, and then after that you will submit your assignment in full.
Thank you so much, sir.
Oh, you're welcome. You're welcome. Ali Sirat, I think you had already question. Yeah. Yes, thank you.
Yeah, sorry, it was, I
Yeah,
got
it's
my answer.
It's
Thank you
okay.
very much.
It's okay.
Sorry, sir. One more quick question.
Please.
For the next week's session, are we going to use the old um Python notebook, or are we going to start a new one?
No, there is no need that we have to use the new one or the previous one. I will just give you a full Python notebook, so no worries about that if you have it in separate notebooks. I will give
Okay.
you a final notebook, and I intentionally didn't give it till now because I wanted you to write it by yourself and 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 understand it properly. Then at the end of the Python course, we will be giving you a final um, notebook of what we have studied, all of them
Okay,
together.
that's amazing, sir. Thank you so much. I was also doing the Python. I have my separate notebook while you were doing the lecture, so it would be nice to compare it to your own notebook.
That's good. That's good. Okay, I hope همگی فهمیده باشن. لکچر ما ختم است. دیگه اینجا